Hello, everyone. Welcome to CTF Radio. In another crazy bit of CTF Radio trivia, we have now shattered our record for most number of interviews done and episodes recorded in a 2-week span. We're at 5 right now. So, Jan, can you give the people what they want? We need you to bring that energy because we're doing all this recording.
Hello, hackers.
Why did you clap? Why would you clap? That's terrible. There's no need
The
to clap.
clapping's great. The clapping makes it's that way people can seek into my part, which is of course where
Oh,
everyone starts in. No,
I
I'm
see.
I'm super excited. We're basically uh recording nonstop. Like I see Adam on the other side of my screen basically every day, half the day or more. It's a dream come true.
But that should be
Um,
normal. We work together. We literally have research meetings
That's
together
true, but
that are
sometimes
virtual.
you can lock yourself in an office, and because you also have access to my office,
I was
I
just
can
gonna
also
say
just hold
I
the
I have a
handle,
key code. My key card opens your office. So I don't know. That was
but
your
I can
choice, by the way. I have
hold
not.
the candle and the handle and barricade the door.
Yeah,
But
sure.
with
You can.
when
You
you're
think
on
you
the
can?
screen, there's no escape.
I
You're
can call
always
you.
there.
I can FaceTime you, man.
That's true. See, this is
Anyways,
the beauty of our working relationship.
I was gonna
Anyways,
say our toxic codependence, but go ahead.
exactly. No, it has been super awesome. We've been, like you said, spending weeks talking to all of the teams in the AICC, and this session is the second to last one that we're talking to, and then
That's not
the
right.
last.
We have 3 more. We have one
Oh,
scheduled on.
that's right. That's
We still have one
right.
to schedule. We have one more scheduled, and this is
Yes,
our. So it's our
exactly.
yes. But anyways,
That's why I'm drinking coffee in the evening. But it's very cool. We mentioned this a lot. But in the Cyber Grand Challenge, which of course was 10 years ago, precursor to the AICC, a lot of the stories didn't get told. And there was an enormous amount of stories to tell. But of course, after the competition, everyone is looking to what the new thing is. Probably, after the AICC, half the teams are going to basically create the next massive AI startup or something. And then you'll have forgotten about the competition itself. But it's really cool that there's this gap between pencils down, you're done writing the cyber reasoning system, to who won. And in this gap, stories can occur. So today, I'm very excited to hear the story of Team Atlanta, who you see on the screen alongside us. Team Atlanta, and the people involved are people that we have been academically friendly and collaborating with and hanging out with and partying at conferences for decades. Definitely cumulatively and especially with
uh-huh.
some of the more senior leadership. So I'm super excited to talk to them. Um,
Yeah, that's great. Thanks for that introduction. So we have, before we get into the team itself, we have 4 great members of Team Atlanta here. So why don't we go around? Taesoo, why don't you introduce yourself first to the good people?
First of all, thank you for your dedication. That's your amazing effort. Okay, I really appreciate what you're doing. I always admire what you're doing for community.
Thank you.
Particularly AICC, that's great. Um, I'm Taesoo Kim. I'm currently professor at Georgia Tech, as well as a VP at Samsung Research. Samsung Research always want me to say those when I be present in public space. Um, at the same time, Team Atlanta, as you can see from the name, most of the team members are from Georgia Tech. There are many people, my PhD students, some people are graduated from Georgia Tech. So everyone's rooted from Georgia Tech in some way or another. At that, many of the team members are leader in their own organizations. We are a multi-organizational group
Mm-hmm.
consisting of KAIST, one of the university in South Korea, and Postec, previously NYU, and we also have some company involved, like Samsung Research and Samsung Research America. So we have an interesting mix of all these practitioners and some of the programmers, engineers, and many of PhD students and postdoc were working together.
That's great. Yeah, I think most of the teams that we've seen are either kind of solidly either academic or industry based. So I'll be interested as we
Exactly.
talk more of diving into like how that dynamic works. So great. Why don't who wants to go next to introduce themselves?
I can go next.
Please.
I'm Hanqing. I'm from Georgia Tech's SS Lab. I'm a CTF player as well. I started playing CTF from 12 years ago. And I have ever played CTF with Team Blue Lotus, Bloop, and later Team Deliverers.
Yeah.
And right now in this AIxCC competition, I lead a team focusing on C and C++ bug finding system. We have around 5 to 6 people, and we made a bug finding system specifically for C and C++.
Nice. Awesome. Do you have a hacker handle since you're a CTF player?
Yes. My handle is Hanqing95.
Nice.
Yeah.
95 because you're such a fan of Windows 95.
Oh, that's my birthday.
God, Jan, why did you have to do that?
You share a birth year with Windows 9. Well, not technically, but anyways, Windows 95 was the pinnacle of computing. Let's move on from Windows 95. I don't know why we're there.
Because of you. All right, great. Well, thank you. Welcome. Minwoo, what about you? You want to introduce yourself?
Hi, I'm Minwoo, PhD student in KAIS, advised by In-Soo Yoon, who's our team lead of the patching team, and I'm also part of the patching team. And there's around 10 of us in the patching team, and I'm glad to be here to introduce what we did for around 2 years, I guess. Yeah.
Awesome. Great. So if the patching works well, it was your success, and if it went wrong, it was those other 9 people's, right?
It's In-Soo's fault.
Just because he's not here, he wasn't able to join us today. All right, HyungSeok, you want to introduce yourself?
Yeah, hi, I'm HyungSeok. I'm currently working at a security research team in Samsung Research America. And previously, I was a postdoc in Taesoo's lab in Georgia Tech. That's why I joined the Team Atlanta. And in Team Atlanta, I usually lead the automatic bug finding team, especially for C, C++, and Java. And while doing that, I also put my many effort to integrate all the system and make them working.
Yeah.
So yeah, it
Well,
was
not just working, right? Working together. That's
working together, right?
that's like the hardest part is what we know from doing it, but also from talking to the teams.
We can talk about lots of drama at the end.
Oh, great.
We have to wake up every single member in patching teams like 5 a.m. in South Korea to handle the last minute hiccup. Okay.
This is great. Okay, so then give us so we got a little bit of details. So roughly like how big is the team? I think it helps kind of frame things. So you have several different organizations and as you mentioned, geographically distributed as well. So what's roughly like the size of the team?
We have about 30 people or 30 and more people working together across countries.
Nice. And are these people like I know some teams did like they had like a core of 10 and then they'd have some kind of people that would work part-time. Is this like 30 core people working full-time on this?
So we intentionally didn't divide the team members in that way. So although half of team members are student, student is far from full-time. When we're talking to students, I have a final exam they have to work on, a final project or research paper deadline. So it's extremely hard to deal with this part-time student. But I think they're smart. They can find their own needs in the team. They can play their own role. But I would say half of team member are student and postdoc, about 10 people, or slightly more than 10 people are full-time engineer. I think this is one of the big strengths of our team. I think I had a hard time convincing Samsung to dedicate resource so that we can at least reserve that much of time, that much of engineer for the duration of competition.
Yeah, that's really cool. And it also, the PhD students kind of reminded me of what Jan talks about with the Cyber Grand Challenge. I think that was kind of your approach, right? It was, you were doing Cyber Grand Challenge, but also you were doing normal PhD stuff.
Yeah, it was just normal. Yeah, you have a deadline, like the Cyber Grand Challenge quals is happening, and there's a Usenix deadline. It's like
Exactly. I think this time we are. I think I have to clarify a little bit. We are open track, meaning that we didn't get the funding directly
Right.
from DARPA to prepare this competition. In other words, we have to find some of the resources to fund our PhD student, which is also tricky. We have to deal with this sponsored project while working on this competition as well. There's so much practical challenges behind.
Yeah, that's great. So can you talk a little bit? I think you mentioned it, but was it, and this is also why, in case people were, Jan made the joke about drinking coffee late at night. We are recording this at 7. And the only reason I mentioned this is because, you know, I think to do this to accommodate your team, right? Because you are geographically located. So how did you kind of structure the communication of the team to handle, like, were you all doing, I don't know, Zoom meetings, or was it hard to meet synchronously? Was it asynchronous? Maybe you could talk about the communication style of the team.
I think we also realized that communicating asynchronously through Slack is most effective way to communicate. We realized that collecting all team members together. In fact, this week is a workshop for the entire team member discussing and pitching about their new idea and what we did during the competition right now. This internal workshop that we are doing every day until next week. But collecting all the team members in the single place in the single time zone, or near impossible. So that we intentionally divide team in a way that they have a similar time zone, so that they can make smaller team get together and talk on Slack. The communication system in Slack, they can just talk casually. But we try to reduce the amount of team-wide communication as much as possible.
Nice. Yeah, that totally makes sense. And actually, I think we probably didn't get into it in the Shellfish interview, Jan, but I know that the Shellfish team kind of did that in essence because you had the 3 universities. And so you'd almost naturally kind of coalesce one university, like a subgroup maybe in there was working on the same thing, because it's so easy when you're all there working on the same thing. I think as the competition went on, it was more and more cross university just because they were, you know, more and more used to working with each other. But yeah, it's easier to work with people that are near you.
My understanding is the early version of our patching system on Shellfish, for example, is very much single university, 2 different single university systems. And then they merged and grew together. Right. The difference is, though, everyone's in the US on Shellfish. And so Shellfish was able to gather very regularly in some third-party places, right? Like big Airbnbs and stuff. I think you guys had an extra challenge there. That's quite. We have a former student who's a professor in Korea, and finding a time to meet that's not in the middle of the night for him and not in the middle of, like, right during dinner time or something for us is tough.
Wow.
Okay,
That's interesting. Now let's get into the cyber reasoning system. Of course, the reason why we're all here. So first question, what's the name of your CRS?
I think Hanqing came up with the idea. Our CRS name is Atlantis. The hero.
Oh, that's great.
He probably asked ChatGPT. I think that's the best name we can think of. We are not very creative, so we leverage the creativity of LLM. One thing we actually realized during the competitions as well, the creativity the human has is not comparable to the creativity that computer has. So I think creativity is not the unique thing for human.
Interesting. Wow. Bold words. Bold words. Okay. So Atlantis is that just the name, or is it like an acronym that backfills into something?
Oh, GPT can make a acronym work pretty well.
Yeah. The question was if Atlantis is like an acronym, or is it just the system is just called Atlantis and that's your final answer?
I think we vaguely call the entire system is Atlantis, but internally there are, I would say, maybe 5 different major components working together. I think I can briefly explain the architectures of what we did in
Yeah, that'd be
CRS.
great, like as a high level overview, and then we can dig in.
I think I can explain some historic aspect of our system as well. Previously, in the semifinal, major focus is a Linux kernel and user space program. So our CRS naturally divided in the kernel focus, which HyungSeok was leading, and user space CRS that Hanqing was leading at the time. And there was Java side as well. But when the competition evolved, kernel spaces naturally disappear because of compatibility issues in OSS first project. So we target the entire kernel people into what we call multi-lane systems. The CRS that target both C and Java at the same time, while keeping two specialized CRS for C and Java. Alongside, there is a patching system universally handle both requests in two different languages, and there are Sharif team that handle the validity of the Sharif. So basically 5 big team collaborating together in CRS development.
Nice. Okay, so then what were the kind of techniques that you employed, like in those, kind of at a high level? So what we've seen so far is, go ahead, Jan. Please.
Could we even back up a little bit?
Sure.
You said basically named 3 different cyber reasoning systems. Were they in the end 3 separate systems or a single meta system that had 3 massive components?
That's a great question. We intentionally, I'll say our team relatively bigger than the other, I guess, so that we intentionally divide the systems in 4 total manner. If C space CRS designed for C doesn't work, we hope that multi-lane CRS can handle. So these 3 systems working really independently. So there's a C component and Java component, and there is baseline component what we call multi-lane. They're really working independently, but of course there is a API layer that communicate with the organization. But internally, there is a really separate component.
Did you ever do contests between the different CRSs? Because you basically did this 3 times.
Hey, you fired one of the teams that didn't do well, right?
Exactly. There's only space for 2 cyber reasoning systems in our cyber reasoning system.
Yeah. I think that's so one philosophy that we have. We have a benchmark systems, probably any other people have as well. We can compare the performance between 2 CRS. But when it comes to the 2 benchmarks which are meet together, we intentionally make some decision to separate them out. The best outcome is that minimize the amount of common, say, bug that we find. We like to minimize that, but when everything is unified, we hope that we can cover many more. So when it comes to, I would say, specialized C work, we push some of the techniques specialized for the C as much as possible. For the multi-lane team, for example, we try to incorporate completely different techniques when it comes to bug finding, for example.
Wow.
Like one great example is symbolic execution. We integrate symbolic execution as one of the ensemble fuzzer inside the multi-lane, but not in the user space, for example. So I think we have intentional decision that multiple CRS cooperatively make the best result, not overlapping or waste of resources at the end.
Now, what about, and sorry to keep running with this, this fascinates me, the plumbing.
Yeah,
there's all this plumbing code.
Maybe a different thing from an architectural standpoint. So you have these different systems, right? So there must be something at the top, right, that's controlling what gets submitted, which we can maybe get into. But then how much intercomponent communication, like if the C component finds a crash, does it communicate that to the multi-lane component that it can then use that to find more bugs?
I think I can explain all this architectural relationship. I think it's good time for HyungSeok to jump on. And can describe about our C corpus sharings and submission and patch the
yeah, you had to get all this working together. That makes sense.
Yeah. Let me briefly explain how our system works. So if the CP is given to our system, then our CP manager component will be came up, and then CP manager will launch C bug finding for C and bug finding for multi-lane simultaneously. And then if they find some seed, then they're gonna share the seed. But if they find some POV, then they will just submit to the CP manager. Then CP manager will verify the given POV really triggered the bug. Because sometimes our bug finding module sometimes miss-submit the wrong POV. So to filter out such cases, we intentionally re-evaluate the POV really triggered the bug. And after that, based on the some call stack, we deduplicate the POV, and if it is unique POV, then we are gonna pass that POV to patching module and self module as well, and wait for the generate patch and self assessment as well, and then submit them with some bundle and yeah, such kind of stuff. Yeah.
Wow, that's very cool. Jan, does that answer your question or?
Yeah, it does. I think the thing that, so a lot of the teams we talked about, I want to say all, but I honestly don't remember. I think all. I have to. Oh, anyways, wrote their own like queuing and plumbing system for communication between components. So you have these 3 CRSs. Do they all use different instances of the same plumbing system, or did everyone make different decisions and you have 3 different plumbing systems to also integrate?
I think we are sharing the same API for submitting and sharing the corpus. Yeah.
Okay,
so we are centralized.
Nice. Cool.
It makes sense.
I think some of the interesting decisions that each of the CIs make, one of those interesting part is that multi-lang team make a deliberate decision not to do any compile time instrumentation. They try to extend the lib fuzzer and add other related code, but not involve in compilation instrumentation. On the other hand, CRS exhaustively do the instrumentations, which mean high chance of failure for certain large scale application. So we have such a diversity in terms of design space that we make for CRS.
Yeah, that's really interesting. That's fascinating. Okay, so then maybe we can start opening up these mini CRSs. So maybe Hanqing, can you take us through like the C++ CRS? Like what are the kind of steps?
CRSS, Cyber Reasoning Subsystem.
Wow.
Yes. So our C and C++ CRS is actually a pretty large scale microservice based distributed system. You know, in this competition, we have a lot of cores, a lot of resources on Azure. We cannot do things like we did in the academic prototypes. Usually, they are just a pretty small tool. So in this competition, I designed a architecture to make it scalable to a large-scale distributed system. You know, there are some kind of challenges like how can we dispatch the fuzzers, the LLM modules, and all of the utilities, other components to different machines, different nodes, different containers. Also, there are some challenges like, you know, the fuzzers are pretty fast, but the language models are pretty slow. How can we adjust the performance difference? So finally, our CRS is based on the Kafka-based message queuing system, and all of the subcomponents communicates asynchronously. In that case, we can easily support components having different languages. For example, our fuzzer is Rust, our fuzzer is C and C++, but most of our controller modules are Python-based. In this case,
that was going to be my question. Taesoo, I thought everything was going to be Rust. This is what
most of them are Rust. But like that's another interesting thing. We scan through the existing libraries that handle those hiccups in LLM systems, like LLM libraries and whatnot. many of them are just Python. There's no Rust support. So we are tied by the timeline, and then we cannot teach everyone to speak Rust. So we have many decisions that just adopt Python, which everyone's familiar with. It's a first-class support from the provider. So we have to make some ad hoc decision, given the timeline.
Yeah. No, that makes sense. Okay, then where does patching sit in all this? Is patching done in each CRS like subcomponent? Like, do they each have different patching strategies, or is there like a central patching system?
So like CRS patch has a separate name called Crete. And the reason why we named it is we thought we were a separate island, and all those like requests for asking a patch for a given POV, they come from all the other CRSs, C, Multilang, or Java. So that's why we named it like that. So we have a separate CRS that does the job of making patches. So we get a detection, like we name the detection as if it contains the blob that actually triggers the vulnerability. And our job is to make a patch for it. We have a big, our system has like about 6 to 7 agents that each of them's job is to make a patch based on different strategies.
Mhm.
And first we do the deduplication to check if the request isn't like a job already done, and then make the patch and do a deduplication again to double check if it's really not a patch already made. And then, yeah, we submit it to the organizers and get our scores, I guess.
Nice. Okay, so wait, this is a great, interesting bit. So all of the patch, like, so is it true you only generate a patch if you have essentially like a POV first?
Yeah.
Yeah, that's an interesting decision we make. I'm very curious about how other people did.
Yeah, we know of two other teams actually that their systems were able. One of them had a very LLM heavy
LLM
system,
heavy.
and so they were able to generate like what they thought of as highly likely vulnerabilities and patches for something that they didn't know how to trigger
Statically. So highly likely vulnerabilities without a triggering input.
Yeah.
We discussed about this like long time.
Is
Whether
this
we have to
technical
make a
discussion or game theory discussion?
exactly technically feasible. I'll say, if your team's goal is place the top or bottom, you probably make a decision that just go for if diff is small enough, like we can identify bugs. Easy, right? Bug and fix.
You gamble.
But if basically gamble. It's really game-based decision. But technically, though, we evaluate internally that how much percentage we can actually make it correct in terms of patching. We realize after running all these, too noisy. So we worry more about system-wise deduction score. Whenever you made mistakes, score got deducted. This factor is so much. If you think about how organizer designed this entire competition, they're obsessed about practical, whatever name of practicality, right? The real world practicality under that name. They want some fault tolerance system and want to reduce the false positives as much as possible. They're obsessed about it. So that we also made such a decision. We can, if you want, patch system is actually made such a component enable. We didn't. They already prepared those components that handle without working POV, but we disabled it so that at the final competition, that's one of the last minute decisions we made. Let's just disable this for the sake of competition. But our system is designed to handle such cases.
Wow, that's awesome. Okay, so then Minwoo, maybe slightly more details about the patching strategy. So were you using just one LLM? Did you have multiple LLMs? What happens if, or I guess did you use LLMs? You must, right?
Yeah, we did use LLMs. And at the start of this competition, we thought like we should break down the process of making patch into mainly two steps. Like the first would be finding where we should be fixing the bug. We call it fault localizing. And then once we get where to fix it, we then give the job to a coder, a patch generator, which should actually just fix the code, which we think is the place that should be fixed to make the bug not trigger anymore. So we had different strategies of finding the fault locations and a lot of strategies of how to write the code. But then mainly, I think the reason why we broke down this was at the earlier stage of the competition, the LLM wasn't that smart. So we thought that we'd have to break down the progress so it could handle easy things and stack them up to a goal called patch. But time passed and the models got a little more smarter. And even when we just gave the crash report and where you think we should patch it and how do you think we should patch it, it just does the job all at once. So we have agents that actually divide the process into fault localizing and patch generation. And there are also agents that just continue the context and the thinking into just a one step. I think this is the place to fix, and I'll just give the patch right away. And I think it should be like this. And yeah, so we have around half and half, I think, that actually divides the process and doesn't. And in addition to that, there are agents that try to extract properties from the code base and tries to make the patch generated satisfy as much features that the code should have, and things like that differ by agents, I think. Yeah.
Nice. What LLMs were you using for patching, and did it differ based on these two different strategies?
We mainly use Cloud 3.7 and O4 Mini and O4, I think. We thought that based on the vendors, the models, they would have a different strength. Like this would be good at this kind of strategies, and this would be better at this kind. But actually, based on our evaluation, we think that a better LLM model does just a better job in most of the things. But we still had to use a diversity of the models, so we just use different agents and LM models in a matrix and just trying to find a set that could cover most of the combinations, I think. Yeah.
When you say you had to use a diversity, is this because of the spending limits, rate limiting, or intellectual curiosity?
I think we could say that, plus we don't know if just because that a model performs better than another one, it doesn't mean that the better one always solves all the problems. So we still have to give a chance to the other models if this could solve it. So yeah.
Similar philosophy to the CRSS's design, right? Is you want to use both because sure, maybe there's some overlap, but the unique parts of each is what you're trying to get.
Exactly. That's how each CRS will be differentiated at the end. Like the bar for finding vulnerability, bar for fixing vulnerability, say 70%, 80%, everyone can get those numbers in day one. But by adopting LLM, next day you can get the patching agent. But what about, can you handle the last minute, the couple more? This is extremely hard. So in other words, in our evaluation, that after evaluating all this model, one more particular model dominate the entire stuff. So that why not just putting all these resources for the one or couple, very small set of LLM, including Cloud Code or Cloud, for example, is our deliberate decision we made.
Right.
All right.
And one more
ahead.
thing about the patching module. Yeah, when I integrate the patching system into our entire CRS, I saw some custom model for patching module, right? So could you also explain about that, Taesoo or Minwoo?
Awesome. That was going to be a question I'd ask later if you did any custom models. No, but let's talk about it now. We're talking about the models. That's great. Yeah.
Should I go for it?
Yeah, you can go if you want. Yeah.
Okay, so there is an agent. Yeah, I forgot to mention it previously, that uses a custom model. it does learning based on code bases and bugs, and it tries to understand what we should give as the context for the LLM to fix the bug, if I understand it correctly, because I wasn't directly in the development. But as far as I understood, it's like it trains the model so that it could provide the appropriate context to the patch generating process. So it extracts symbols and things like that, and tries to rank which is needed to make the sound patch. And yeah, it works like that, I guess.
So I think I can elaborate a little bit more. It's a Llama 7B based instruction fine tuning that we did. The intention was that, like again, as I mentioned before, one major large scale LLM dominate. We are looking for either we can quickly solve some tedious challenges faster than the other because there's a time-based scoring stuff. This kind of incentivize the time, but otherwise we have to take long time to validate whatnot. Our custom model designed to identify this common easy target quickly, faster than the other. Another one is that we specialize everything for C, particularly in the what type of symbol they have to look up, so that given a particular repository and sanitization report, and these are the symbols that you have to look. So we have to do a lot of instruction tuning for the model. So another interesting part that we've been experimenting with is that given a completely unknown repository, can we do online adaptations against them? It's a little bit controversial. It requires a lot of resources during the runtime. There are new techniques like LoRa, like the last level optimizations in the model way. You can do things in 30-minute and 1 hour period, so that you can do some optimization for completely unknown repository, so that we can perform a little bit better than the other. We couldn't evaluate effectiveness very well. First of all, we don't have an unknown repository that the model didn't see, unfortunately. But we have such a component in it. This is one of our,
This so far is unique among all the teams you talk to. This is the first ML technique that isn't query and LLM.
But like, again, let me clarify. This is our hidden component. There is 4 people dedicated for the custom model. Our original intention is to adopt some of the Samsung's custom code model during the competition. But again, this is the open source requirement. Things make it extremely difficult for the company to contribute that way. So that's why we adopt this Llama-based one. I would say this is one of distinctive decisions that we can make as a team compared to others.
Cool. Yeah, it's really cool.
But we cannot assure it to work well, but still.
Well, yeah, I mean, it'll be interesting seeing that trade-off, right? I mean, because like you said, taking a while so you're actively fine-tuning it on the repo that you have. That is really cool.
Yeah, online adaptation.
Nice. Wow. Awesome. Hi, I'm very excited to see the results here. This is crazy.
That could.
I mean, we had talked about and hypothesized that everyone would have roughly the same shape of CRS, but that is definitely not the case. So there's a lot of, there's a lot of variance even within, I think, the CRS.
Yeah, and in fact, so far we've been hypothesizing the 2 shapes, right? Because we have the CyberGrand Challenge CRS with some AI splashed in, some LLM querying splashed in, and that's the people that live in the program analysis world and visit AI. And then we hypothesize an AI first approach, which is something closer to theories, for example, right? That they're really an LLM focused crew. And then we thought, that's it. Those are the two guys. And you have a third one.
There's people like us, like LLM wannabe.
Yeah.
wannabe.
But you're actually AI researchers.
So,
that's super
great.
Cool. Wow. Okay, so then maybe we can hit some of the other components. Like I think I'm particularly interested in like the multi-lang like CRS component.
Yeah.
So how does that work?
Actually, our primary goal is to support multiple languages. So first, we need some abstraction layer for executing any language like Jaeger or LeafFuzzer based harness. So to do that, we make some hole in the Jaeger and LeafFuzzer by using shared memory and some semaphores. So to do that, we can easily get some coverage feedback and easily execute the input what we want to actually execute. So after that, we focus on how to leverage a large language model to improve the fuzzing process. So we especially focused on the how to generate the better input by using large language model. So to do that, we did some LLM based dictionary generation. So for example, if we give some function, ask LLM to generate some interesting dictionary, and based on that dictionary, we can do a dictionary-based input mutation in the function level. So previously, we usually do just collect the all dictionary and mutate inputs based on all the dictionary rather than function level dictionary. And we also, by using a large language model, we also reverse engineer the input format. And based on the reverse engineer the input format, we do some grammar-based fuzzing. So
Nice.
before doing that, we try to utilize the previous some static analysis-based reverser, but yeah, the quality of their output was not that good. So we switched it to large language model to reverse engineer the input format. And also we have some LLM heavy modules called MLLA. So basically that's we first ask LLM to figure out which line will be the bug candidate, and then we ask LLM to generate the Python script that can generate the blobs hitting that lines or triggering some bugs. But after doing that, we realized that just blob generation script is not enough. So we ask LLM to generate the input generator written in Python and also input mutator written in Python as well. So after
And the mutator. Oh, that's
yeah, mutator
cool.
as well.
So this then plugged into the fuzzing loop, essentially?
Yeah, right. So
generating the mutator is not something I've heard of before. That's really cool. Well, okay, at least not with that in this way. That's really cool.
Yeah.
So
that's just something we're gonna publish, okay?
Hands off.
Yeah, basically we ask LLM to generate some mutator that can mutate the input that already triggered the specific function to the target function. So yeah, in that way we can improve our fuzzing process a lot. Yeah, and also we try to leverage direct fuzzing as well. As I mentioned, large language model could point out which line is suspicious lines. So based on that output, we can guide our fuzzer to reach that target lines as well. So that's yeah.
How do you guide the fuzzer in your CRS? One thing that we ran into, the reason I asked this question, we ran into this very poor quality of directed fuzzing techniques, and we had to have several different techniques in the artificial CRS to try to do directed fuzzing.
Nice. In CRS in multi-lane component, we are also not that good. Because if we do better, we need some core graph, a contour flow graph to calculate some distance between the target line and current coverage. But I thought that we do not have enough time to do that. So what we did is just calculate the score based on the coverage and the target line. For example, so basically our bug candidate has not only target line, but also a should be taken line, which is a kind of path for triggering that target line. So based on this information, we can calculate the seed. So for example, if the seed touch some should be taken line, we give the seed a 2 point, something like that. So
Yeah.
based on that score, we just do directed fuzzy. And also, if we find some crash or POV, then we deprioritize that bug candidate because we already found that bug. So we do not have to focus on that line. So after that, we deprioritize that bug candidate and not to reach, not to reach
And this
that
is
target.
deprioritizing is basically, you reduce the frequency with which that seed is selected for mutation.
I think we have another directed fuzzing component in the user space. Hanqing, do you
Yes.
want to explain a little bit more? Or
We also utilize the directed fuzzers. We actually have two cases can invoke the directed fuzzer. The first one is actually the Serif report assessment. When the Serif team sent us a report and a target line, a suspicious line, then we launched the directed fuzzer to verify if the target can be triggered. Another case is the delta mode. For the delta mode, we firstly call language models to reason and infer some suspicious code locations, and then we put it into the directed fuzzer for some kind of directed fuzz.
so I think we have a little bit serious directed fuzzing component in the user space. They divide the entire code graph, the control flow graph in the multiple step in a way that this is a notion of the graph centrality notions in all these nodes. If you reach here, they're going to expand the coverage significantly. We select those components, try to divert, try to direct the fuzzer one step at a time. But in theory, it worked great. But in reality, instrumentation fail all the time. That's a reality.
Yeah.
With the theme of competition. So, but we have those components deployed in final version of the CRS we submitted. The performance is not guaranteed, but we have those components.
And this was like
right.
this is even on the source code level, like inserting those annotations is difficult, right?
Yeah, exactly.
Just to clarify for the audience, because they may think, well, yeah, binary instrumentation is like hard, but this is, even, and Jan, I think you ran into this as well.
Yeah, we ran into this exact thing, like source annotations, and then everything blows up.
So particularly the form of competition can be more regularized in a way that they can promote innovations in that level instead of dealing with this. Well, again, it's what the name of practical real world software, right? But we like to figure it out what's impossible stuff possible with LLM. But there's so many things that we have to deal with. Like you probably experienced the Docker version changes. Like our system completely failed. Not even working. The baseline changes. This is out of sudden everything change, everything break. But this is not what we want to validate through the competition. So we kind of limit our exploration capability during the competition.
Yeah, and this I think is something that we've heard a lot in these sessions now as well. I think on the other side of it, one of the big criticisms of the Cyber Grand Challenge was that it was done on a toy operating system with toy programs.
Exactly. Architecture is 7-bit architecture.
and so figuring out that middle ground, but AIxCC went almost all the way in the other direction, right? It's like, you have to, So it's super hard.
The nature, I think, the other thing that's come out of a lot of these interviews is each team kind of had to make that research versus engineering trade-off, right? Of like how much, Jan's big push on our team was to try to get them to do something simple that just kind of worked, which they completely ignored and did something else. But like Jingyu's team 42 Beyond Bug, they wanted to test, like they deliberately didn't do crazy researchy stuff because they wanted to make sure that the stuff they were building they were confident would work. So yeah, it's just a crazy, it's the reality of the competition, the reality of real world code, right? All this stuff kind of comes together. Wow, cool. Okay, so are there any components? Okay, are there any components we haven't touched on? Is the Java component, the CRS, Is it kind of
And
similar-ish to the
then,
C? Like, did you have a Java specific one? I can't remember. Or was that the
yeah, there's a
multi one?
Java specific one
Okay,
as
right.
well. But I think in terms of design, not particularly different from what we are doing in the, I would say, C space, but there are several things that we like to clarify. Fudging in
You love
Java
Java.
is a little bit tricky, but we hate Java.
You're off of Rust. Taesoo says no Rust. Rust sucks. It's
Okay,
all Java from here on out, right?
okay, Java is pretty unique. On the other hand, like all the software engineering community work on Java for decades. Decades is not right word. It's like half century per se. We assume Java has symbolic executor. This symbolic executor is really based on Java. Everyone is working on Java in the software engineering community. In reality, not working. We spend tons of analysis on top of Java. There's so many Java JVM dependencies and crazy library and dynamic nature of the Java, like function near impossible to do in practical software manner.
There's
Like
a
we have
saying
to
that
do with zookeeper, right?
there's a saying
We
that
have
the
to,
fastest path to insanity is Java Pathfinder.
yeah, right. But like one thing that we observe, there's a pretty interesting thing is there's no memory corruption. Memory corruption can happen anytime in the C program. On the other hand, in Java, there are certain places that fuzzer can trigger. Like there is sanitization hook. You know, like, hey, there's a command line injection. There are some like process scripting things, and like there are certain places that or reflection, class loadings, deserialization stuff. There are certain places that the bug, what we call security bug, can only happen. I think this make our design of the fuzzer very unique in a way that we can divide many of those components into tools like explorations of the code coverage and exploitations to reach the bugs in a way that you can put some of Sentinel for Jagger, for example. You have to put intentionally. Unlike in the C, we try hard to trigger memory safety issues, but in Java, it's all about how to make Jagger happy. We find the input, Jagger can realize this is a buggy. So all the reasoning behind this Java is how to make this Jagger, how to understand how Jagger behaves, how to Jagger recognize those. And patching side is also tricky too. The how to fix the bug in Java. Hey, create another exception routines. Like, hey, what about we wrap around the entire entry point of the Java? Say, hey, catch the exception. No bug like escapes. By nature, it's just secure languages. It's all about how to adjust those, I would say, practical stuff at the end. But if you see the actual patch that they provide as a sample, right, if there is an out of array bound access, create the exception routine that prevent this return. It's pretty, in some sense, extremely easy to fix in that way.
Mm-hmm.
But probably that's not what developer want. But like there are several practical challenges in that regard, specific for the Java as well. I think the quality of the Java output is not desirable. I would say if I'm the Java developer, probably you have to think completely different way in terms of writing patch and whatnot. But because we are CRS, automatic agent can just deal with this particular instance of the bug. There are so many easy ways in Java, unfortunately.
Yeah, that's interesting. I mean, it kind of is surprising, like you said. I think I'm kind of struck with looking at the software engineering community. There's so much research on like Java and
yeah, everything is Java. Like creating code graph in Java.
Yeah.
We thought it's like, hey, there should be tool like people working on, but none.
Yeah, and even though, obviously C and C++ are older, but I feel like those fuzzing techniques are much newer than Java, right? I mean,
there's a difference of communities too. I think security is so focused on like the real world impact, the final thing. We found these bugs, and software engineering, you say have increased code coverage, but it doesn't quite survive reality.
The state of the art patching schemes from software engineering community is all about how to deal with no point exceptions in Java, which security community don't care that much about.
Right.
So I think the bar here is slightly different, or expectations of the competition is slightly different than what software engineering community care about. But it's all about security critical one.
And
Yeah,
so
no,
then
I
you,
think,
you
like,
kind of go ahead.
I was just gonna say, like Jan said, the security community and even the hacker community, I think, is focused, maybe over focused on C and C++ targets and being able to fuzz those, whereas kind of Java languished, in my mind, mainly because like Java targets like J2EE, these are like big enterprise apps and there's not a lot of open source of these apps as well. Like a lot of them are closed source, and that makes everything more difficult. Yeah, I think it's pretty fascinating to think about. But yeah, Jan, you were saying.
From what to put time on in the competition, again, Java kind of, or anything that's not C or C++, kind of puts us in this interesting situation of, do you want to re-implement like the fuzzer? Or because you could implement the AFL for Java, right? And then take all that time, or you could try to make Jazzer work. I think because the Jazzer was the reference, everyone basically went with it.
I mean, you had to, because then if you submitted something, they wouldn't know that it crashed.
Yeah, exactly. So yeah, you'd have to translate it anyways. So yeah, I don't know. It is a little bit frustrating in that regard. I don't know what other language would have been better though.
Yeah, exactly. The usage of the Java side, particularly in the hospital environment and enterprise, are humongous, I agree. But at the same time, fuzzing probably not the best possible security tool in the Java side. Probably they need, like, the language is memory safe by default, but there are some Java specific one that we are looking for. Probably fuzzer is not the best one for the job. But at the same time, there is interesting Genie component. Not sure you guys handle or not.
I have
It's
no
a
idea.
multi-language aspect that we wanted to address.
Oh, wow.
There's a Java side, there is a C side that they're going to put the native code from the Java side. We are very ambitious to handle those. We ended up giving up.
Oh, no.
Yeah, I was gonna say, we did some research on that on the Android side of stuff, and it's very hairy.
Yeah, I remember the anger support for that, even like for symbolically executing through Java into C. It's absolute hell.
Exactly.
All the subtleties, yeah.
We have those support in mind because organizer explicitly said there's a possibility that multi-language can appear. During the competition, they clarify you have to modify the language the harnesses the project specify. I mean, hey, this Java plus C, which language are you saying? Should we handle like entire, because it's a Java-based program that involves C, probably written in JVM.
Right. Yeah.
Then how to handle this C program that potentially buggy because it's not part of the scope. So there's so many practical things that we have to care. So we ended up.
Yeah. Wow.
Yeah.
That's interesting.
You have to scope it for you, and that's why I think. I mean, part of that we've talked about before too on this podcast is like the competition itself is also trying to hit a moving target, and is trying to stand on the cutting edge. That allows get better and better. Suddenly, yeah. So it's just crazy. I think probably looking back, if we have the organizers on the podcast and we ask them what would you have done differently, it's very much easier to see in retrospect, right?
So I think you whenever new sample challenge appear, our mindset completely change. So there's a backdoor in the program. There's a timeout, which we don't care. As a security researcher, it seems like this is what they care. So we have to start support out of memory issues. As a bug type, like these is like open our mind into what I have to work on. Actually, this is how they drive us. What we have to focus on. We all about, hey, we have to deal with the UAF, these most difficult challenges that everyone care about, but not, you have to handle all these little one as well. So
yeah, Yeah, it's really interesting. Okay, cool. So let's so what would you say? I think we've talked a lot about your CRS and I loved all the details. So what would you say, because we've touched on a lot and maybe we've already touched on it, but what's like the secret sauce of your CRS? Is it all right, actually, I'm just gonna stop there.
I think we can make turn and can talk about
Yeah.
something.
Yeah.
But I think the diversity of our CRS is I think our secret sauce. One component might fail, as we saw in the multiple rounds. Other people's CRS might fail, but we hopefully our CRS, one component fail, other CRS can take over from here, so that there should be no missing simple box that we are missing
Nice.
during the competition.
That's great. Yeah. And that's a almost like a diversity of designs even of the systems, right? Because you have like redundancies built in. It's not just, I know a lot of people think of diversity like, yeah, you just run a second fuzzer. That's, that's great, but it's a same copy of the same fuzzer running on the same target. Like that's not giving you anything in terms of robustness of your system. So
on another secret sauce.
Yeah,
Well,
please.
a little bit controversial, but when I pitched this idea to Samsung in a way that, hey, we need the systems, we're gonna deploy this one after the competition, like when everything is open source. Hey, give me this amount of engineers, or I'm gonna hire everyone for this competition. Their KPI, whatever performance metric, if you don't win, we're gonna get fired. Well, it's very strong argument. If you don't qualify for the semifinal, we're gonna quit. So they're really doing their best. This is one of the secret sauce we have.
Nice, motivated people. I like it. That's great. Wow, that's awesome. Cool. Okay. Yeah. So then I think we've touched on it a little bit, right? Even you touched on like models and the ecosystem changing for AI. So how has, for each of you, how's your personal outlook on AI changed by participating in the AI Cyber Challenge? Were you skeptical at first, and then were more, maybe Taesoo, you want to take that, and then we can go around?
Yeah, I can talk about years. We are the skeptics, particularly semifinal. Our motto after evaluating all existing LLM and whatnot, our motto at the time, hey, we're gonna deal with this competition. We're gonna show the powerfulness of traditional buzzing technique. So that, hey, we don't need.
And by then you had a customizable on the fly fine tuning model.
Is like now AI wannabe, okay? But like at the time, even when we preparing for the semifinal, if you see I think we're gonna share this semifinal code base as well, I believe. If you see our code base, we don't leverage any LLM, no LLM allowed for the final, semifinal, except patching team, of course. So we were skeptic at the beginning, but everything changed. Like, hey, there's a new code interpretation happened. Like now LLM can do something crazy and reason everything about Python. Hey, now there's a new function code, tool calls, and whatnot. So much easier to deal with this weakness of LLM by using current state of code tool. So I think there are a lot of interesting components we couldn't do by using traditional techniques, particularly static analysis and stuff. The LLM by default outperform the most of the static analysis that we have, particularly given this complex software.
Yeah, I mean, it's crazy. It's really impressive.
Yeah.
And I think for people that don't know, Sue has a very prolific career in security and program analysis and all kinds of areas. You know, when you say that it's actually better than those techniques, this is a real reasoned, and like your background really speaks to that. So I want the people to know that it's this isn't just like an uninformed opinion that like, man, vibes, they're better. Like, no, it's real, right?
Yeah.
So one of the anecdotal example right now in our lab is that when people doing reverse engineering all the time of hidden binary, like unknown binary, now people just copy and paste assembly to ChatGPT. They realize it's better than IDA, better than like Jack or not. They start relying on LLM every single workflow that we have in terms of reverse engineering or traditional software analysis. It's a new world.
Yeah. Yeah, it's really crazy.
And it's, I think that's the beauty of this competition, especially because it is in many ways kind of the next level of the Cyber Grand Challenge, right? Is you have, if a bunch of AI bros came in and, you know, we're saying, yeah, it's a new world, it's just a bunch of people saying this. But we have
Yeah.
7 teams full of some of the top program analysis
Yeah.
researchers in the last several decades. And they're saying this. And that's, I think that's one of the biggest values of this AICC.
Yeah, exactly. We are joking all the time. This best outcome of AICC is to convert the top hacker to the AI domain. Just expose them.
Yeah,
It's not
exactly.
about the AICC, CRS, whatnot. They're gonna outdate it pretty quickly. This pace of AI is crazy. Now we open up so that we start working on those crazy stuff at the time and start integrating those
and it
into
also,
our
I
job.
think it also speaks to like the AICC as a competition catching wind right when these models, because just like you said, Taesoo, I think us is very similar. I was incredibly skeptical when this came out, but I was like, yeah, we should definitely do it. That sounds like fun. Like, why not do it, right? And like, sure, if fuzzing and program analysis is the best approach, like that's awesome. But then, you know, but then even like towards quals, the students showed us some results and you're like, wow, it seems like it's kind of working. And then as things got more and more, it just got better and better and really kind of took off to this level where a new model would come out and then boom, we're patching things that we weren't able to patch before. And it's just wild to me.
Yeah,
It's
go ahead.
I had a lot of conversations with kind of DARPA PMs and so on in the interim between the Cyber Grand Challenge, the AICC, and I think one of the things that people point to is this exact effect. Back in the original non-Cyber Grand Challenge, the DARPA held for self-driving cars, right? In the early days of these grand challenges, one of the biggest side effects, that first challenge, no car made it to the finish line, right? It was like, from some perspective, it was a failed challenge, but suddenly you had all of these top researchers that were now enthralled in self-driving cars, and that leads directly to me taking a Waymo on the way here today, right? So it's like, yeah, it's awesome.
Wow. That's cool. Okay, I actually have an engineering question before we get to the end. We got about a little bit left. So you mentioned this kind of a big system, right? You have several CRSs running. So what was like the local dev story? Could you run each sub CRS as its own thing locally? Did you have to run the whole system? Like how was that dev experience like?
I think HyungSeok is the best person. Yeah.
Yeah. Personally, it was horrible to me because I was
to dev or to test?
Yeah. So basically,
Yes.
I ask every single sub CRS to run their CI and test a lot before integrating into a single unified system. But when I try to pick them and integrate into a single CRS and run it on the top of Azure, it does not work. So every day I ask the developer of that CRS, hey, here is the bug, so we should fix it, something like that. So yeah, it was very horrible.
I think one thing that I observe, but I'm not using cloud all the time because I'm just academic. I like server, not cloud. I just give me the root bare metal access. I'm gonna do everything by myself. Don't touch it. Okay. But one thing I realized is that all the members complain, yeah, you should work great, like perfectly in my local setting. When it comes to Azure, everything breaks down.
Yeah.
Oh, we even test much larger scale in the local systems, but when everything migrated, everything break down. Like magically some name server like got dragged. So the uncertain file system slow down, like and then network file system is suddenly very slow. Like there's so many uncertain stuff in the Azure space that we couldn't like make our CRS happy. I think HyungSeok is the one got all the blame.
Or the glory for bringing it all together, right? That's kind of well, I feel your pain. I've told this before, but for quals, that was my job. Is the students messaged me like a month before the deadline and was like, "Hey, we don't have any way to like test our system. Like we should really be doing tests like on every, commit." And I'm like, "Yeah, you should be. Why aren't you doing this?" And so I had to wait. It took me 3 days to figure out how to even build and run the system locally on my machine. Like it was so complicated and there was so much institutional knowledge among the people that it was wild. And then taking that knowledge and coding it into the CI and getting builds running. And of course, those aren't big enough and you got to run your own clusters. And it was just, but that was for quals. And I was like, I'm done after this. I can't do that again.
I think
wild.
It's a good time to talk about one of the bugs that we experienced.
Yeah, please.
I think probably HyungSeok can describe, or Minwoo. You guys know the context about the fuzz keyword that we rely on in the patching team?
I know that. So basically, the rule that we should not fix the harness code, because if we fix the harness, then everything will break. So we should not fix it. So to mitigate that, in the patching patching module, explicitly specify that if the file name contains the fuzz, then we should not modify that file. But there was some case that the CP name has OSS fuzz dash something like that. So
no.
Yeah,
the last minute integration test that we got are with OSS fuzz and name.
Oh no!
I'm not sure you guys like. You know that the previous one, the Nginx.
Yes.
Like, now
we didn't run into a bug with this, but I remember like scrolling through our like CI logs and it's OSS fuzz dash whatever, and then there was whatever's. I remember now. It didn't.
Like there's your OSS fuzz and project name. It's like
That's
our
his
CRS, patching CRS, never produced anything in this.
Oh no!
So this is so critical that we have to wake up every single one of them at 5 a.m. and fix it.
It was right before. At the time, I already wrap up everything, and I already submitted our final version. But I feel like something weird. So at the time, I checked again everything.
Whoa. Stop. So this is what, like a day before submission
before.
or the night before?
No,
A day,
maybe
a day.
6 hours before the final submission.
Wow.
So I just,
hey, you guys submitted really early the first time.
yeah, right.
Yeah, that's our goal. Let's submit everything is 1 day before. It's actually almost worked out. Almost worked out.
Well, it did. It saved you.
Yeah,
Because if you had done it the last minute, there'd be no time to fix it.
Wow. Okay, so
it was
6 hours
horrible.
beforehand is when you found that bug. God.
Wow.
I'm getting flashbacks. I remember quals. It was like the day before, the night before the submission, before they extended it. And one of they'll remain nameless, but they committed some code that was they were testing some feature and they wanted to drop a file on their local file system to turn it on or off. And they ended up committing that code of looking for a file with their full home path. And it just so I think that was testing if we would submit patches. And so we never would have submitted patches or something in the quals. And thank God, like somebody found it at I can't remember. I think somebody's going through the logs and being like, hey, this run of CI is not submitting anything. Why is that?
Well, interesting. By the time that like the competition finished, we had a very lightweight analyzer that would use the various LLMs on every PR and tell us like, hey, this might be an issue. This might be an issue. It was very useful, especially that final push.
That's interesting.
Well, it wasn't a great issue. Do we actually tell the whole story of what happened 45 minutes before the submission?
We should probably leave that for like a retrospective episode.
I want to make everyone feel comfortable that we also made these mistakes.
Yes.
But
okay, just real quick story. We submit. We're done, right? I happen to be milling around looking over people's shoulders because I can't not do that somehow. And our we can name and shame because there's no shame because it wasn't her fault. But Itzin is handling the final submission, and she's okay. And this log, she's looking. This looks good. This looks good. This looks good. And then as she hits Q out, like to quit the whatever less, right? I see a exception pop up, And I'm like, oh, wait, go back. And she looks at it, and it's in the the plumbing. It's in the plumbing. And she says, I've never seen this exception before. And it's 45 minutes before
and meanwhile, there's like 20 people there. There's like 3 people actually like working on computers. Everyone else is just kind of waiting and for the final like we've submitted. And then we hear that I've never seen this error before, and it just gets dead silent.
And it was just a last minute thing got committed that raised. I think we might have talked about it. That raised the timeout to beyond the range that Python can handle. Because we're like, we don't want the critical things to time out, so let's let them run for 3 billion minutes. And it just kept blowing up. It was a very stressful time. Manually edited for various technical reasons. We couldn't do a full system redeploy. It was special.
Think about
Anyways,
it. We are developing completely autonomous CRS systems. One line, one token, just destroy everything. Oh, we couldn't deal with this.
And it's interesting because it's kind of I was trying to think that's like a very almost contrived scenario, right? There's not many scenarios where you just ship a system and you're completely hands off and it just works, right? You're a company, you develop software, develop a website, you can push fixes all the time. You can release new versions, but it makes sense for the competition. But man, that like not knowing or like these close call situations that we're talking about, that really gets you like right here.
And also, LLM makes everything non-deterministic. So in our case, after submitting our version, I also tested, but we failed to generate the patches. But I just thought like it's because of non-deterministic of LLM. So I just went to bed to sleep. But after waking up, I just feel like something weird, and then check again everything, and then we realized that we have a DAB issue.
Oh wow!
Oh.
It's and they're very complicated systems too, just like you said. Like, well, yeah, maybe okay, sure. Normally we patch whatever. We'll have 2 patches at this point in the testing, but like LLMs can be weird, and other scheduling can be weird. Fuzzers are non-deterministic, right? All this stuff is non-deterministic.
Hard drives have finite storage, and if you want to run this system for 10 days straight, and it logs anything, you could get fucked, right? Like it's terrifying. And here's the reality: something is gonna fail, right? Like you just have to hope that it's in a non-critical component. And in the CyberGrand challenge,
or
every single CRS had some failure like this.
Enough redundancy into your system that, like, I was going to think of the Jurassic Park, life will find a way, but your CRS will find a way, right? There'll be some path to some bug.
Right.
That's great. Okay, so now with this like close call, like heart stopper out of the way, so what place do you think your CRS is going to get? Sorry, did I cut out?
Top 3.
Yeah.
Otherwise
people lose their jobs, Taesoo.
HyungSeok, sorry, but this is our KPI. But yeah, we wish for the best. But I think our motivation even at the beginning is don't be shamed by not being top 3. It's not about money. It's not about everything. In fact, Georgia Tech wants us to donate the rest of the money, so we are not getting penny out of it, but we still win the competition. Otherwise, not sure I'm gonna survive in the security community. But we really did our best last 1.5 years. I'm very proud of my team members, all these lead working like 24/7 all the time.
Yeah, it really becomes kind of like an all-consuming project, right? And like you said, there's so much stuff you could do, right? Especially as the models get better and you get more ideas, but you have to temper the crazy, like I want to develop this crazy new component versus I'm going to really make sure this thing works.
But I think one thing that worries me the most is that AIxCC, for example, like paper review, research grant, I've been rejecting or declining all these requests, saying I'm gonna focus on AIxCC. This is the main things last 2 years. I'm not doing anything else. But now I have to find something to work on.
So you don't have to review papers. That's what you're saying.
I have to start reading paper.
I kept telling our students on the last couple of days, it's like after an event like this where you focus your entire life for this long, there's no alternative to just being lost and depressed for some time. Like in the Cyber Challenge happened to everyone, the
Right.
winners, anyone.
Exactly.
And yeah, that is, by the end of the CGC, I was pulling these insane 32-hour days where I would work for 24 hours straight, and then I'd go home and sleep for 8. And so I'd like shift over time. And that was like my entire, everything was in that competition. And then it was over. And I wake up after DEF CON and like, now what? What am I going to spend 24 hours
Nothing to
working
do.
You're a PhD student, man. Write papers, do research.
Yeah. It takes a while
to remember how to do that.
Yeah.
Oh man,
it was awesome.
That's so funny. Cool. Okay, so then what? I think you've kind of talked about it, but maybe you could talk about what's kind of the plan for, post. Is the cyber reasoning system? Is something going to happen with it? Are you guys running with it? Is Samsung going to use and commercialize some of it? I think we're all interested in there's obviously the things will be open source, but we're also interested in what the teams are kind of going to do after the competition.
I think that's a great question. So the research side that we have a list of research subjects we want to explore on top of CRS. They're going to continue. But in terms of real world deployment, we are actively working on deploying our CRS version for internal Samsung repository. It's the same open source version. We create some UI in a way that developer can use this one. We extend a few things in a way that we can involve human in the loop process. Doesn't have to be completely autonomous. Human can give some hint about the patch they want to generate and etc. So we are making the systems not complete autonomous, semi-autonomous way internally for internal repository that we have inside the Samsung.
That's great.
So
and
all
this
these
is
people
your
working,
workshop,
yeah,
right?
yeah. This is
yeah.
basically workshop that we are doing so that they can share the internal structures as a formal manner. But we already created those front end for the CRS so that our deadline for internal deployment is near October this year.
Wow, that's cool. And how are
So
you
it's
handling?
not even that it will live on; it is living on.
Yeah, they're already planning for it. That's great.
Exactly.
So can you? And of course, we understand if there's things are proprietary and you can't talk about it. But can you talk about how you're handling the harness creation problem? I think for me, that's one of the hardest parts of applying fuzzing to any new target, even when it's me doing it.
That's a great question. It's a great question for the community. And OSS Fuzz project has some form of automatic harness generations. And this is one of our internal agenda for next year. So once we are done with this, we're going to automate the process of harness generation. But harness is a little bit tricky. But currently there's so many existing harness for the internal repository that we'd like to improve the quality of the bug finding. And we can also provide the patching candidate so that automatic agent run overnight and provide the PR for the corresponding researchers and developer.
Wow, great. Cool. All right. So we're kind of getting close. So looking back over the last year and a half, 2 years, what would you have done differently? So is there an approach you'd take differently, or I don't know, even a team structure? It's kind of an open-ended question of whatever you think you'd do differently, like looking back.
HyungSeok, do you want to mention? We have like jillion list of what we would do differently.
Yeah, HyungSeok says get somebody else to run and test this damn thing, so I don't have to do it.
Yeah, anyone want to describe what you wrote it down for our workshop? You can go ahead.
I think the first one is building the high quality benchmark at the beginning rather than building them later, because it drives us to develop our strategy and our system. So yeah, but in our case, the format of AIxCC competition is keep changing, so we should change our benchmark as well. So it was very so yeah, that's the first one. And also let me check. Oh, I think it would be better to explore more how to utilize a large language model better than now. For example, so in our module, we give coverage feedback to large language model to generate better generation script or mutation script. It is quite hard because we have some context length limit and we have some TPM and we have some credit limits. So how to efficiently provide some these coverage information or other very useful feedback to large language model to make them better. Such kind of things, yeah, we have a bunch of things related to large language model things.
Nice. You just have to convince Samsung to build their own large language model now.
So we have.
Yeah?
Yeah,
All
guys.
right. Nice. I love it. Anybody else have any things that they'd do differently or approach differently?
As for me, so I'll go first. In the patching team, as you rely a lot on the LLM, I think if we knew that LLMs were going to change this rapidly during the competition, I think I tried to keep in mind that this is going to change a lot because during the competition, we made things for the previous models because we thought they're going to need it. We did our best in making them, but after a few months, a new model comes up and it can just do it by itself. So we just
Doesn't
lost
need
a lot
the
of
help.
like development time, and I think that was very sad, I guess. So trying to keep in mind what could be changed and what is gonna be definitely needed, and trying to keep that in a list and do that in a order priority. That would help a lot in the competition, I guess.
It's a very
Nice.
interesting position to be in because you have to kind of gamble on technology progressing at a certain pace, looking ahead. Because if you,
Exactly.
yeah, you don't make those you don't make those components and you end up needing them, then we'd be here. I wish we hadn't gambled that LLMs would get so good.
Yeah, and it makes actually what you're saying echoes a lot of our patching team. So I'll be sure to introduce you to them because in Vegas, because there's a lot of I think they too were sad by how much effort was having to keep being undone and redone, and like the techniques that used to work on the old models don't work on the new models and actually decrease performance. You have to undo some of the hacks that you were doing earlier, and it's just like kind of like you're like a treadmill. You're just trying to like chase that good patch, but it's hard.
Yeah, exactly.
Question I have real quick for Hacking 95 over here. How is the AICC in your mind? Because you've been involved in some top
Yes.
CTF teams, top CTFs. How's the AICC compared to a CTF?
I actually feel like it is the next version of CGC. So compared to the CTF, in the CTF, we usually focus on how to exploit the bugs, how to exploit the low quality bugs actually. But for this competition, we are more focusing on the bug finding. It is pretty different from the CTF. In the CTF, we usually do the reverse engineering by using human. In this case, in the competition, we need to replicate ourselves to make our agents, our system to mimic the ideas in our mind. That's also the philosophy for us to design the system to replicate the seasoned security researchers into the agents.
So idea, a CTF where your only interface is the LLM. You have to tell the LLM. You have multiple LLMs, maybe agents, et cetera, but you just have to guide the LLM. I got this idea when you said replicate.
Yes.
LL
which
Live
is-
CTF.
Yeah, that could be interesting.
Yes, we already have some try in our internal CTF in Georgia Tech. We also have a CTF course, and we already run our system along. We already run the system along the competition, the internal CTF in our university.
So we again, it's similar to what Minwoo mentioned before. A year ago, we created the CTF agent that writing exploit for every single challenges that we have for the class. so that we can use as a either benchmark and CI and whatnot. Didn't work very well. She achieved like 4 weeks of competition, but after that it's complete failure. But now everything changed. So I think it's a good time for us to try again and start building. And one of the predictions that I have is the one prediction from AI community, there will be some 1%, 1 billion market cap company will appear. Like similar here, similar thing will happen in security community. There's a 1% CTF player win the DEFCON CTF with the help of LLM or AI in general. I think truly less than 8 people person with the help of AI, they're gonna win the competition sometime soon.
And their handle will be LLM Heart.
So they're the manager of LLM or worker of LLM. So LLM
Yeah,
instruct them
exactly.
in a way that, hey, do this for me. So LLM can figure it out how to
Amazing.
submit the flag.
Wow. Yeah, that'll be super interesting. I mean, we've already had, like, going back to kind of what Jan was alluding to. I mean, there's a history, I don't know DEF CON finals, but definitely quals of people qualifying as a single like a single person team.
Yeah.
So it'd be
I
super
think
interesting.
the challenge is more in the organizer side, because now everyone has a LLM access, like trivia and it's not even challenging anymore. I think bar for most of the average user is so high thanks to LLM. Like how to deal with this?
Last DEF CON
Extremely
quals,
difficult.
there was a pseudo-random number generator reversing challenge that we were working on for a while. I wasn't involved in this, but the team was. And eventually they kind of hit some wall. They pasted the whole code into an LLM with the seed that the server gave them when they connect, or not the seed, the random number that the server gave them when they connected, and said, what's the next random number? And it was correct.
Wow. Wow.
It was insane. I mean, it could have been blind luck, but it was insane. Yeah.
All right. Well, on that note, we're going to have to say goodbye to our guests. Hey, thank you, Team Atlanta, for joining us today. I think we had a great conversation. I learned a lot from you all. So I'm Adam D. You can find me online at Adam Dupay. He's Zardus. You can find him online at Zardus. We're CTF Radio. You can find us online at CTF Radiooo. O's not zeros. You can send us questions through email at ctfradioo@gmail.com, and your questions might end up on a future episode of CTF Radio. Goodbye. Thanks.
Thank you.